Okay, welcome, and thanks for attending this talk. I know it's 5:30, so some of you might be tired. So we'll try to keep it more interesting and entertaining as much as possible. As mentioned, the presentation and the title, should be entertaining. And we're going to show you how we found all these bugs in Trend Micro software. And as you can see, the title is I got 99 trends, so we try to do a game of words there, and the root shell, not a hashtag, is all of them, or better, how we found more than 200 remote code execution vulnerabilities in Trend Micro software. So the agenda for today and the presentation and format is pretty straightforward, it's nothing complex. We're going to show you a little bit, it's going to be our introduction, a bit of disclaimer, and the motivations that drove us to do this kind of research. Why Trend Micro and not others. And then, of course, we're going to focus on the targets we selected for this research. We're going to show you the vulnerabilities. Some of them, of course, we cannot show you all the vulnerabilities because of the time and so on. But we picked the most critical vulnerabilities, and from the exploitation point of view, exploitation angle, the most interesting exploitation angles we had to face during the research. So this should give you some good examples of what we found across different Trend Micro products. Of course, we want to show you the how, not just the what. How we found it, which approach we took, and also show you some of the mistakes we did along the way, of course, the lesson learned, and so on. And then we will also, since this is the first time we are presenting this material, and we wanted to give a full exclusivity to in the Box Amsterdam, because we really like this conference. Today we're gonna also release some unpublished exploits in one of the Trend Micro products that we're gonna cover later on. So be with us, and I hope you guys are gonna benefit from this presentation. A little bit by myself, I'm Roberto Suggi Liverani. I have a Twitter account, Malrish. I do this as a passion of mine, and I do publish my security research on my blog, blogmalrish.net. I've been speaking at other conferences, and I like to find bugs. Beside me, Steve and Seeley.
Okay, just a little bit obligatory slide. A little bit about me. I'm an offensive security researcher and content developer. I do a little bit of independent security research and on client-side vulnerabilities as well as server-side vulnerabilities. I like to do other things too, like not just computers. Like I study Wing Chun, and I'm a diver as well. And yeah, so. Back to Roberto. Thanks.
Okay, a bit of disclaimer before we go into the content of the research. The first thing we would like to point out, we didn't do this against Trend Micro. We have nothing against Trend Micro. We don't want to put down Trend Micro. We strongly believe that given enough resources, assets, time, people, you can find a similar number of vulnerabilities, if not more, affecting other products. And actually, as a matter of fact, after this presentation, we test different products, so it's not just Trend Micro. As a matter of fact, I will be publishing a bug I found some time ago in McAfee. So it's not just disclaimer, just to make things clear, because we got some questions. Why did you pick up Trend Micro, not others, and so on. But the opposite, what we want to do is to actually share what we found, how we found, and so on. So that's the takeaway from this presentation. Motivation. We noticed on Twitter there have been reports published about code execution vulnerability affecting certain Trend Micro products. So that triggered our curiosity. We noticed these two tweets you see there in the slide. We say, wow, this is interesting. There's code execution, so it's very critical vulnerability affecting a security vendor. So that piqued our interest. We say, in the moment you have remote code execution vulnerability in one product, most likely there are others, and that was one of the main drivers to start this research. But it was not the only driver. Of course, there were different, let's say, motivations or reasons. One of the things is that Trend Micro also have a ZDI, so that the acquisition program for vulnerabilities. That was also another reasons. But the other thing which is interesting from the security point of view is that when you try to find vulnerabilities in security software which provides security, well, first of all, it's a huge attack surface. But the second point, which we will see in the slides, is that the code which is running, most of the time is running with a privileged user like root or system. So if you're looking for vulnerabilities in these components, most likely you can target them to have access like root shell, or you can have a system privilege on a Windows environment. So that was also another interesting part of it. Another reason is that there's been quite some research in the past about antivirus and endpoint security. We wanted to focus still on security vendors, but not antivirus per se, but all the other appliances and application and products which typically are found in enterprise networks. And you will see some of them in a few slides. Last but not least, I mean, if security, I'm gonna quote this, if the security industry is going to promote defense, then they themselves should not be defenseless. I mean, we've been involved, I mean, we did a lot of disclosures, and sometimes we did disclosure to products of other industry, not security industry. And sometimes these companies, they don't understand the bug reports, and it's very difficult to have a dialogue with them. In this case, it's a fast communication channel because they understand the business, they understand their vulnerabilities, critical vulnerabilities affecting security software. So also in terms of reputation and image, they have best interest to resolve this issue. And for us, it's not a big hassle to go through.
Exactly.
The targets, these are not all the targets. These are the targets we're going to cover today. The research is still ongoing. And this is the order we're going to follow. You see the mobile security for enterprises taking off. The only reason why is because we have 0 days and they're currently working on resolving this issue, so we are not disclosing vulnerabilities in that part. Nevertheless, we're going to show you a demo. We have a demo for this later on, so that you can see some of the vulnerability we found in that product as well. Mm-hmm. Testing approach. The testing approach we took in this research started from responding or attempting to respond to this question. How can we fully compromise a product without user interaction? That was the aim. It all started from that question. And all the testing approach we followed was always trying to come back to this point. And when you try to put yourself as a researcher into this position, you will only go for the type of bugs which are either command injection or that lead to remote code execution, for instance, SQL injection and so on. But we also look into weaknesses in frameworks used by Tremicro products, or also, for instance, in authentication bypass, and chaining these bugs together. Having a remote code execution that you can only trigger after authentication is not as much as critical having with the bypass authentication. So the type of the vulnerability class that you're going to see during the rest of the presentation is mostly command injection or vulnerability to resolve to code execution and authentication bypasses. This is what we took. We didn't go for a full methodical approach testing software. We went for low-hanging fruit and just concentrating our effort into this kind of vulnerability classes. One of the things we also did, of course, as part of this approach, and one of the advantages of testing Tremicro, for instance, is that you can download their products. They're all available from their website. Once you download the products, you can then install it locally on your machine. You can install it in virtual machines. So you have full control, and you can actually then try to get the source code, try to get the binaries, do some reverse engineering, try to basically switch from a position where you're in a black box position to a white box up testing approach. Why this shift? Because once you get into the white box, you have more vision, more view of what the software is, and you, in the best case, you have the source code, and you can go through the source code and be really methodical in finding bugs of like OS command injections. Another thing we took as testing approach, there is a lot of things in terms of malware analysis and so on, a lot of research as well in that field. But all the techniques which are valid for malware analysis can be applicable also for bug hunting and for vulnerability research. Why? Because we want to analyze how different components interact with each other. we want to analyze, for instance, the traffic generated by one component, how it's talking to a server, who is talking first, and so on. And you will see some examples later on when we talk about some of the products, especially data loss prevention is one good example of these techniques put in application. The other thing we are looking for patterns, okay? When we say pattern, we are looking for a way to identify if there is a single or a common mechanism across the different targets. What we noticed that when we picked more than one product in Trend Micro, we noticed that certain functions or certain libraries were used across the targets. And we can imagine why. Sometimes they are rushed to go to market, they are rushed to deploy the product. It's a big competition, after all. Endpoint security is a huge industry. So, and I guess probably the same developers teams, they worked across products. So we found instances where there were similarities. So we're looking for patterns. And one of the patterns we found is what you see in this slide. We saw, for instance, Trend micropods with web interface using a single point, like a gateway, for instance, taking requests with methods and parameters. Now, one of the approach here is to basically map as much as possible, try to get all the different methods and parameters and so on. And then, if you do find a vulnerabilities in a common point like this one, in a pattern like this one, then you are in a good position to find a lot of other vulnerabilities using the same pattern. Of course, we did some part of automation in this, considering the number of vulnerabilities we found. The automation part, in this case, for instance, consists in understanding which requests, which methods are valid, okay? So that part can be automated, for instance, with a script, which then feed the results into a web proxy, for instance. But the point here is to create baseline requests. So valid method name, for instance, coming back to the here, and this is the method name here, and then you have the parameters of this method, okay? So this kind of information, that can be, for instance, spidered, crawled from the web interface, if that is the case. And it was the case for one product in particular. But the other thing two products, yes.
At least.
But the other thing is not always relying on the web part, so on the front end. We have to go behind the scenes. And what we did was to basically try to find other methods following or using that single point API DLL, and then that were not exposed through the web. And that leads also to the discovery of other vulnerabilities that typically are not found if someone is just looking at the web interface. So we had to go back to the code, again, testing approach, going through the binaries, the libraries, the source code, and fully get the mapping out. These are some examples of what we did. Very simple. It's nothing complicated. We went through strings into different XC or DLL, and then we try to build a list of valid methods, valid parameters, and then basically iterate that.
Hold on, one sec. We've lost it.
Iterate that basically through a web proxy, for instance. And that's part of the automation. But of course, the automation part is one part of it. Then you need to basically manually verify if the request is valid or not. And then if it is valid, then you can try to attack it. And that's what we did. But that part, it's only manually. And that requires some time, of course. We lost it again.
Yeah. Okay, we're back.
Thanks, man. Yeah, I think it's this.
Yeah, that's the... Okay, thanks. So yeah, we don't know regular expressions. That syntax in the previous slide, just ignore that.
But nevertheless, that syntax helped to find approximately how many? 80?
Yeah, we found 80, and then we found a whole bunch that was not in the client-side code. And we were like, well, I bet that wasn't tested for security issues, because that it's not even reachable from the callbacks in the JSON, right? In the web interface, the client side. So it's probably not tested for security. So we run it through our test case and our test harness, and bang, 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 it spits out vulnerabilities. So, oops.
Yeah, it came out as a nice testing approach.
a lot of these were also pre-authenticated too. So a lot of the times we get, we find a vulnerability and we can reach it, and then it's running at a high privilege, so we get root or system, and it's pretty much like, well, we don't even have to bypass authentication in this particular case, and sometimes we do, and it really just depends. But
yeah, in this particular case, I mean, if you go behind the scenes, again, testing approach, you might find out in the positions where the developer really didn't think that you will ever reach that particular component or that particular method, so they assume, unfortunately, wrongly, that, okay, authentication is not needed for that because it's not exposed.
Or they develop it and then they just forget about it. They're like, well, we'll come back to that later and we'll add that functionality into the front end 6 months later when they haven't fully finished it. And then, oops, too late, there's vulnerabilities in it. So.
Exactly. So the screenshot you see here, this is one of the demo live we're going to do later on. So pitfalls and difficulties. Of course, we had issues. It's not that we found vulnerabilities so easily. It's not these kind of things you find in 5 minutes and so on. It takes time, of course. Also, we had issues with the software. So Trend Macro, yes, it's good. You can download all the products, as I said before, but the products, you need a license. So they give you some trial license, but it's limited. You have 30 days, and then it's not full, and you have problem with the Active Directory integration. So we had to go around, take some interesting approaches, and you will explain after. Yeah. And yes, so these are some of the problems we face along the way. And of course, mistakes and laziness from our side. One of the mistakes was that once we found I don't know, SQL injection, we're just jumping on the SQL injection and we forgot about all the rest. And then we found to another page which was close to that, like OS command injection and so on. So sometimes we're so greedy to find only a class of vulnerability that we forgot about the context of the application. The other thing which we didn't really do well is that you need to take a little bit more patience, because all these products, as I mentioned before, are typically for enterprise network. So normally in your laptop, you should have an enterprise network alike, and then deploy the product, use Active Directory, use Exchange, for instance, and so on. So you need to have the full thing to make sure you cover as much as attack surface, because otherwise you just have a box with a web interface and that's it. It doesn't work, or you can only do a few things.
Yeah. It's not like testing like Reader or something with 50 meg files and then that's it, You need a 100 gig or whatever, and then you need a whole bunch of RAM for enterprise type software. Not because you really need it, but just because the software says, hey, we need it, and you're like, you don't. Yeah,
there's a quite huge additional attack surface that you can enable only if, for instance, you synchronize one appliance with the Active Directory. Mm-hmm. Then suddenly you see you have 10, 50 new pages available to you, and you can attack them. You can try to find vulnerabilities in those. The other thing as a difficulty is that some of the bugs we found, of course, they require authentication. So one of the most challenging, I would say, was to find authentication bypass. It's actually, probably we can say it was the most difficult part sometimes.
Right, so the thing is, right, we all know that, security is only as good as your weakest defense or strongest defense or whatever, but one authentication bypass means you can reach all the other vulnerabilities post-auth. So, I mean, that's, you just have to have one or two, and then it's just pretty much game over at that point. So, if a lot of this stuff is post-authenticated and whatever, then we just focus solely on the auth bypass and then, continue on. But we're not looking for things like, interacting with the client or things like that. This is server-side software. Well, we want to keep it server-side exploit. We don't want to send you a link, you click on it, blah, blah, blah. No. It's just pop shell, game over, walk away. This is what we're focusing on. So,
Cool. Let's now switch to the targets. I'll hand you the.
Oh yeah. Yep. So the first target we're going to talk about. This is not the first target we tested, but this is the first target we're sort of looking at today. I honestly think we spent maybe less than a week on this one, so we didn't have too many findings, but nonetheless still interesting. So it's basically what is it? It has it's like a filter, right? It stores a whole bunch of URLs and known URLs that are hosting malware, and that if a user gets an email with a link that it's known to be hosted with malware, if you click it, this smart protection server will be smart and intercept it and be like, hey, it's malware. So this is basically the function of this software. I actually only learned that half an hour ago, by the way. So I just looked at the code and that's
talking about the laziness.
Yeah. So it's good old classic PHP and Apache. So it's sometimes my favorite type of bug to look for. There's like lots of attack surface, but they sort of, I guess by the time they developed this software, they sort of cleaned up a lot of the vulnerabilities, and a lot of by the time I got to this, so I only found like 3 command injections and stuff, and a couple of really simple privilege escalations, which is just like kind of embarrassing, I guess, but you know, nonetheless. And the Java code base was actually quite good because they did like a lot of parameterized SQL, and they were checking for like if they did do a command in the code, they were really like checking for that, like for malicious strings and things. It was all whitelisted and stuff, so it was like, yeah, I'm not getting past that. So the approach though in installing it was a bit ghetto. So basically, like we couldn't get a license, right? And I don't like to pay for software if I'm testing it, just because. So, you know, we download patch files and can't install the patch and blah, blah, blah. So we quickly just like modify the patch file or like whatever, and then run the installer and then remove all the version detection and things like that and the license check, and then it will just override all the files and dump all the PHP or Java or whatever it is. Because really, we're like, in this particular case, we're just like focusing on the code so much, not so much like the environment, what have you. And yeah, we use an old vulnerability to pop a shell to be able to patch it, and then, you know, we're all good again. So, so this is just a simple one. Like, this was actually introduced in one of their patches, so I find that quite ironic, actually, but nonetheless. I'm not sure if you guys can see that, but yeah, it was basically just a simple GET request with a command injection. There was nothing like amazing, but it was post-auth, so, you know, like, we didn't actually find an auth bypass for this product, but I think we will come back to this and like go hard and look for like a decent auth bypass. And yeah, pops a simple shell, and then there's a couple of like privilege escalation vulnerabilities, right? There were simple ones. It was like, you know, in the rc.local file, there was a couple of web serve user writable files that we can just write commands in and wait for the box to reboot or whatever, and then execute code as root or commands as root. You know, simple stuff. You know, and also, this was the rc.local. There was 2 different files in there that was, you know, web server owned and writable, so we just like leveraged those. And also in the cron tab, they kind of screwed up that. That was like really simple stuff, and we were just like, okay guys, oh, and your kernel is like miles behind, by the way. So we were like, I don't know. And yeah, like pop some like root shells very simply. So, you know, it was, when we come back to this product, it will be like focusing on auth bypass, and then we go past all the auth stuff and look for all the critical post-auth bugs like command injection, code execution, whatever, all that fun stuff. Oh yeah, you can see like the kernel version there. Like I was like, yeah, they give up on that stuff. So, you know, like I said, we'll come back to this, but you know, it was riddled with like XSS and stuff, but like, you know, I'm not going to really report that, you know. They can figure that one out. Like, we're looking for more critical issues, so we're that type of thing. So, and this was actually, like I said, it was introduced in a patch. So it kind of gave us a gauge on like how other future products will be. If they're introducing security issues in patches, we're like, okay, this could be good for us. We could keep auditing the other software and hope that we get something out of it. So, like I said, the results are hard to conclude. We're still ongoing for this particular target, but nonetheless, they patched it and we got a nice bug, so it's cool. I'll pass you on to Roberto now for the next one.
Thanks. Data loss prevention is another product we targeted, and when we started the research, it was not end of life. Now it's end of life. Maybe we contributed to kill it, perhaps. We don't know.
I think we sent like 100 vulnerabilities in this target, and I think they started trying to patch them, and then they were like, actually, guys, I think we're going to end of life this one, and that was it. And I was like, guys. Like,
so we just to be fair, we put end of life there. Okay, so what is it? Data loss prevention, I'm sure you heard about it. It's typical product that you put in your enterprise network to avoid any intellectual property theft or any data loss. So you want to control your employees and the documents, whatever they use, and avoid that these documents leak out of the organization and so on. So it's an appliance, and it works with, it's a server, and there is also some client agent components, which is the interesting part when we did this research. And of course, the agent works on the workstation. So the agent is responsible for analyzing, parsing all the files and the documents, and then sending that information back to the server. The server on the other side has the policy, contains all the policies. So you can say, okay, I don't want any credit cards to leak out of my network. So basically that policy is then pushed through the agents, and the agents then check if there's any credit card data inside, and if there is and is going out, it will be blocked. And then report will be generated inside the DLP web interface with a nice graph and so on. So this is the typical enterprise security product. And there was previous recruited research on these products. I think it was in DEF CON, I think.
Yeah, no, Black Hat.
Black
last
Hat.
year and the year before, they identified some cross-scripting stuff, I think.
Yeah, they found other type of vulnerabilities. So it was quite interesting to resume also the previous research and see how far we could go. The other thing is, I mentioned about agent. The agent software is also including other third-party software, which is KeyView, and we will see in a moment. So under the hood, we have a Tomcat, a web administrative interface, which is listening on a certain port. We have a daemon, which is listening for the agents to connect and then send the information. And then we also have another service, which is listening. And this is also used by another component, which is called remote crawler. And I'm going to go in this in a moment. The client software is KeyView, as I said. It's a component that Steve will introduce later on, but it's responsible for parsing and extracting information from the files on the operating system. So in terms of statistical and many vulnerabilities, there were at least, I think, 42 that lead to remote code execution, and 26 of which without authentication and so on. We were going to cover 3 of them. Of course, we cannot cover all of them, but what we are selecting is the most critical and most interesting ones we found along the way. And one of the approach, as coming back to the testing approach part, for this product in particular was to basically run it locally, go inside, check the services, check the service location when they run, extract all the source code, import the source code into an ID like NetBeans or Eclipse, study the code and so on. The other thing which we basically did was to go through the web interface. And one of the points as a tester, for people here testing, is that you really need to use the application as supposed to use at the beginning, just to get as much attack surface out. And one of the things we noticed is that you could download a remote crawler component, which is an additional component that optionally you can run against the agent. And actually in that component, we found an interesting vulnerability, which we will introduce in a moment. But this is just to show you guys and that basically sometimes you have that icon there, you don't want to click and because you're lazy or you're going too fast. But sometimes being curious helps, and you want to try out as much as functionality as possible. The first vulnerability we're going to introduce is actually related to this component here, the remote crawler agent. It's about Java unserialization. And this is interesting because when we run the remote crawler, as I said before, we took a malware approach. So we analyze everything. In the moment we click something, we're running Wireshark, we're sniffing, we're trying to see what it was doing. We're using sysinternal tools to map and so on. So one of the things we notice is that, I don't know how much you can see, but basically we notice that it goes here, the DLP crawler server invoker. On 8080, this is clear text, okay? And then what we notice here, there is nothing about authentication header, nothing about session cookie. But what is interesting is all the Java objects here. So the first thing that strikes to mind is maybe this data will be unserialized, and if that is the case, then we can basically leverage that. And of course, there's been previous research on Java unserialization attacks, and tools like YSOSerials make very easy to create payloads, which will then trigger the code execution. I think we have to.
Oh. Drop a signal again, I guess. Ay, caramba. Oh, it's at the bottom, I think.
Sorry.
Sorry, guys. Hang on. Wait.
He's running, I see him.
Okay.
Wait, no.
This is kind of... Ah, man. Oh, it's up. No, I don't know.
I think it's coming back.
It's back. Yeah. Okay. Yeah. Let's continue. Yeah. We gotta kind of speed through, I think, because we got still a lot of slides and less time. So let's go.
Of course. So one thing we noticed, there is no authentications on. You can use YSO serial. So we embedded everything together with YSO serial to create the exploit, and it worked. The thing which we noticed also that this vulnerability actually, whatever the remote crawler was connecting back to the server, that code is running as a system on Windows. So that was a way to get unauthenticated code execution as a system level. Yeah, still off.
Okay. It's on now.
Oh, it's on. Okay. I need to look here now. So this is where the bug was found, and you see the get object involved, and this is basically the get object which will be called once the unserialization happens, and this is where the vulnerability is. You can see the 8080 here and the same crawler invoker right there that we saw in the previous. Can we go back? No.
Does it work?
Nothing is working.
Okay. Well.
Yeah, here. Oh.
Now try. Okay.
Yeah, cool.
Yeah. So like getting root shell was like pretty much like.
That's the example that we just explained.
Yeah.
Let's go fast because we waste
a
little bit of time. So the unauthentic cross-site scripting, this is another vulnerability we found. As we said before, without user interaction. It's actually without user interaction. Normally cross-site scripting, you send a link, so you require user interaction, the user has to click and so on. In this case, basically, it's different. And this vulnerability was quite interesting. One of the things which we notice when we look into this is that the agent, whatever the agent is running on the workstation, connects to the server. And of course, when it connects, it sends some data, like, for instance, computer name and so on. The connection between the agent and the server is encrypted. So one part of our research was to basically decrypt that connection. There was also some certificate pinning embedded in the agent. So we didn't have the private key to open the certificate and then use the Wireshark with the certificate and so on. So one of the approaches we took was to use API monitor and then basically identify which libraries we're using to do the SSL encryption and decryption. And then we just set hooks on these APIs. In this particular case, we saw that the SSL encrypt packet, this function was inside the encrypt DLL. And actually, by hooking all these calls before the packets will be encrypted, so in memory, we could see the clear packet before passed to the function, okay? This gave us a lot of information. We see that this is most likely proprietary protocol by Trend. And then we see here some clear text information. Basically, we studied this protocol, we studied all the different communication, and that basically led to find this vulnerability. One of the things you notice here is computer name, and you see it just after here. So if you respect all this syntax, basically our exploit was to basically put something cross-scripting payload right there. And basically we noticed that whatever computer name will be rendered in different pages of the administrative interface. Now, of course, if you want to use the product, you will log in certain point in time, and when you do, you will get the cross-scripting. So it's stored, unauthenticated, because the agent is only sending this information. But here again, there is nothing which is using. There is no username, there is no password, no credentials, no nonce. Nothing. This can be replayed as we speak. The only thing, he has to go through an SSL tunnel, and he has to go through directly to the server, okay, because of the certificate pinning. and you see one screech should appear in the agent management. So if the administrator goes to check the agent status, it will be affected. This is where some of the, there were actually two cross-cascading. This is one, and basically was when this JSON array put function was called. And basically, you see at the very end here, when the get linked URL also is called, you see here that it's creating the HTML content. And basically, some of the parameters that are passed to this, that are here, basically, appended to this URL link, basically contain the cross-cascading, and then you could escape from the load href function here. So that's why it was able to get the cross-cascading in there. So it was quite interesting. It's not the standard cross-cascading that you find. We had to understand how the agent works, inject into the traffic. And then the other thing is the agent, it doesn't register. There is no registration process between the agent and the server. So there are other vulnerabilities we are not discussing, but basically anyone from an IP address which has connectivity to the server can register itself as an agent. The most important point is that it talks the right protocol. And once it provides the right protocol, then the server will just blindly trust that it's an agent. How was discovered? We just covered that. KeyView, you want to cover this?
Let's go, KeyView.
Cool.
So another component that, that the software had actually was like this component called KeyView. And you know, it's sort of, after a little bit of Googling, we saw that there's some vulnerabilities in it. It kind of got interesting. And we realized that it like passed like 200 file formats or more, and we was like, oh my goodness, this is going to be bad. So, you know, and then the remote crawler actually does the parsing itself and runs a system. So we were like, okay, so file parsing, 200 plus formats, running a system, sounds bad. So the first thing we wanted to do was work out how we're going to actually test it, because the remote crawler would just pick up a file in a directory based on a rule as part of the DLP solution, and it will run a scan over it and look for whatever strings it's looking for. So we're looking for binaries that we could just pass the file format directly and to be able to automatically test it, preferably something on the command line, right? And we eventually found something that like filter.exe, and it calls this function down here, and then it's listed here, and basically it's passing KeyView filter.dll, which then does all the loading for each particular file format DLL. So that was a nice entry into testing the application. We didn't even have to write up a standalone exe to be able to test the DLL, the parsing. We just used one of their own DLLs, so it was nice. So it was very simple. It was like, you know, command line here, fuzz file, and then there's an output file, right, because it does a conversion, and it converts to something. So I just put junk, and, you know, literally like while one fuzz forever type thing. And I do a lot of like file format fuzzing anyway, so like I have a lot of corpses that I've developed or built using my own tool sets and stuff. So we had a lot of very minute, like covers a lot of code base, very targeted file sets already ready to go. So it was just pretty bad. So the only one we'll talk about today is this one, is because it's still, I think it's still 0 day in the KeyView. So any other component using KeyView, this bug is still live. Yeah, we tested it on some other products. Which product was it?
McAfee.
McAfee,
to be fair.
Okay, McAfee. So if you're there, yeah, you're also vulnerable to this. Yeah, so it was like a Stack Overflow when passing RTF files. I think it was in the font table tag. So if it broke out of the font table tag, you'll get a Stack Overflow. And yeah, it was pretty simple. I think we smashed the stack and everything like that, and yeah, it was. What was interesting about it was the fact that the actual overflow used the data from the actual font itself, obviously because it was in the tag, at the start tag. So when you close it off, it'll use the rest of the data from the actual embedded font, which is just like hex values already for you. So I could just like modify that and like gain control of things, and that sounds bad, but yeah. And like it was more or less a situation where it was very simple to exploit. You know, we didn't have like ASLR or SEH or stack cookies or anything, so I was just like, I don't know, okay. And it can be used by like a drive-by download, right? Like Google Chrome or something. Like you download automatically. You got a DLP solution rule that picks up a downloads file, scans the file, triggers Stack Overflow in a system process. Yeah, like it was kind of bad. I honestly, I think I whipped up this in like 10 minutes or something. I don't know, and pops calcs and stuff, and yeah. So and with 200 plus file formats, I honestly lost track of how many vulnerabilities we found in this. After they would just send us an email saying, okay, we're going to end of life this product. We were like, okay, whatever, just pretend like we didn't find these or something. So yeah, and now we'll move on to Control Manager. This one was an interesting target. Sorry if I'm going a little bit fast because we're running out of time, so I just want to make sure we cover some content. This was kind of like the heart of Trend Micro products, right? Like their other products would connect to this, and it would like offer controls off to other products and things like that. And in that case, it was really just like a huge attack surface as well. And it had like a lot of different components integrated. You had IIS, PHP, ASP, compiled code. I mean, you name it, pretty much had it. I think it even had Java somewhere. It was just like, guys, this is a security nightmare. Like lots of vulnerabilities in it, but more so, again, running like, one good thing I will say about this actually is that a lot of privileges, like the database was running as like a low privilege and things like that. So if you did get shell or something like that, you're running as low privilege IIS user or the database network service thingy. And so it's okay. It's not as bad, You can still do things, obviously. And one of the motivations was actually, God, he's probably watching this, so anyway. This is like a bug he found in like 2016, like last year, in some PHP component, and I was like, okay, cool, I like PHP, and this software has PHP, okay, let's do that. And so I decided to start looking, and that's kind of like the motivation behind it. So we'll talk about a couple of the bugs, but this one was probably one of the most interesting ones because it was pre-authenticated and it gave us the ability to bypass the authentication. So it was a blind SQL injection, like pretty much standard SQL injection, and it was time-based, so it was kind of hard to detect, I guess. You could only do time-based, and allows for attackers to steal hashes and things like that. No sessions were stored in the database, as far as I remember. At first I thought, okay, you've got to crack the password. That's kind of crappy. You have to crack the hash and all this kind of fun stuff. Not so fun, actually. But then I realized that it's got like a pass the hash vulnerability, and I love these types of bugs because it's something that developers like overlook, and they're like, you can log in with a hash, and it's like, well, what's the point of hashing things if you can log in with a hash? So it turns out that worked, and so basically you can steal that hash, log in, and get a authenticated session cookie thingy, and then we can use that to reach all the other vulnerabilities like we talked about. This was disclosed as EDI 17074. And we could have chained that with all the other bugs. So basically, this was like my little simple proof of concept. It would just detect the target if it was vulnerable, steal the admin hash, log in with it with no cracking, and then just get an authenticated cookie, and then we could take that cookie and go ahead and use it against other vulnerabilities. And for example, this was another vulnerability, and then you could just like do another SQL injection, and this one would execute commands, and then we could just do that, and then yeah. Actually, the first one, it was kind of weird, actually. I still don't quite know why. I haven't really looked into it. But this one, you couldn't actually execute commands from it for some reason. I think I stuffed up my query, but you probably could. But I couldn't get command execution from it initially. But then there was lots of other bugs to get command execution from, so it was all good. And then, that executes as network service. So, yeah. So we can combine the bugs. And get some sort of like unauthenticated code execution initially, and then probably we can find like a privilege escalation or something, even like another trend microkernel driver or something, and just like, get like system or something. We didn't go that far because we were just looking for the initial point in, and then that was it, okay? If we got system, we got system. If we got root, we got root. If we got network service, hey, it's network service. So yeah. Also, another bug we found was this PHP file actually, this mod DLP template match drill down thingy. they had a lot of this PHP code was replicated in multiple folders. So they would have like a mini PHP application in one folder and the same application in another folder. So if there was a vulnerability in this particular application, it's going to be in this one and then this one. So then they would just like replicate their own vulnerabilities in their own product. So there'll be like 3 cases of this one bug because, you know, they replicate vulnerabilities. And this was, I forget, I think this was a file inclusion, yes. Like a local file inclusion. But I could, you know, even with modern PHP, you can obviously still get code execution from that. So we wrote exploit for that, and yeah. Yeah, and there's the shell and thingy. So we're only II user from IIS, so we'd have to find another bug to get root because that's crappy user count, so, you know, all good. And then we had some success with that one, and yeah, we found like lots of bugs with that. So ZDI did a really good job in like sending the reports off to Trend Micro and getting them patched, and that actually helped us a lot in terms of dealing with the vendor and things like that. We probably wouldn't have gone as far with the research had we not had that, simply because of the motivator obviously behind it, and also we don't have to deal with the vendor directly. We don't have to, you know, try to clarify things, et cetera, et cetera. So we'll move on quickly to InterScan. This one was another interesting target. This one it inspects web traffic against like known patterns, you know, anti-malware, URL reputation, and things like that. So it had somewhat similar to Smart Protection Server. It implemented the Struts 2 framework, so lots of Struts code in Java, which was kind of alright. And we found like a lot of bugs in that too. A lot of previous bugs too in the previous year were found in this, or at least some of them were found in the previous year. So I was interested to look at the patch for that and see like how we could like maybe bypass the patch for that. And yeah, so this was like the patch initially for those previous RC vulnerabilities. And it was like, you know, an escape parameter thing, and it took some characters and then it tried to escape them. It was kind of like just a blacklist. It's pretty simple. So it was, you know, I like escape the escape, right? You know, just like, it was kind of embarrassing, I guess, for Trend Micro, but I could just like escape what their escape and then like still do my backtick fun and then like execute commands, yeah, as root. So, you know, and we missed some bugs, you know, that's how it goes sometimes. And CoreLogic found a couple of RCEs, but you know, we try to be really sharp and look at every single entry point, right? So we're going to cover the most critical one of this one, which was the do post mount device bug. This was kind of interesting. This was in their REST API interface in part of their struts code. You could reach it via the mount device endpoint. It took some JSON and via the post body request. And you can see there, it's pulling a string mount device, and then it's passing to this exe UI helper command, and that kind of I was like, oh, that looks interesting, you know, naturally. What does that do? And then it passes it to another, creates like a string with this interesting string here, and passes it to exe command, and I was like, oh, what does exe command do? And then obviously that turns out to be, well, not quite a good thing, and execute commands. And you know, if you remember, this kind of string looked interesting as well, so we'll talk about that in a sec. But yeah, and it was pretty much game over at that point for code execution. So you know, and yeah, like the full proof concept was like this, right? So we'd have the backticks in, we'd set the command to mount, and it would try to mount this and using this command, and then it would get code execution unauthenticated. So, but as root user, so it was basically as bad as it gets. But the patch was quite good. If we look at the patch here, the first thing it did was check to see if the request was coming from like local hosts. So that's not the ideal approach. SSRF can defeat this, but you know, it's okay. And then it does a validate user if it's not coming from local hosts. So the second thing to notice was they called this function is valid mount device. And that was so that was kind of interesting. And then we were like, okay, what does that do? And then that just does like a string match check on mount on this file. And if it's not valid, doesn't exist. And so we were like, okay, that's good. That's a good patch, you know? Good job, guys. So that was for that bug. And the UI helper, if you remember before in this particular function, it was like building up a string with this UI helper. It turns out that this is just a very simple shebang wrapper that would like execute commands as root. It was SUID enabled and things like that. So, you know, we could just call shebang and get a root shell out of that too. So, you know, that was bad. A simple privesc. And then we had a whole bunch of stuff patched by that too. So they did a really good job. I mean, I was really happy with that. I checked the patch and, you know, they did a good job this time. It wasn't like the first time. So it was nice and cool. And we had an authentication bypass for this product as well. So all the RCEs as post authenticated could be reached by this auth bypass bug. So it was cool. And we got a demo going as well. This is not a live demo because we're running out of time, and so we thought we might. But this basically is just a little proof of concept that we've got, and yeah, we write the exploit for it, and we set the target, and we pop a shell, and it's root user right there. So yeah, it was very simple. The good thing about web bugs is it's like fast, reliable, and that kind of thing. So yeah. We'll pass you on to Roberto for threat discovery and plans.
Thanks. Okay, this one is another product, Endoflife. Actually, it was still downloadable when we started the research. So probably they decided for this time for real to kill it before we will investigate it. But anyway, this it's another appliance which was the purpose of this was to basically monitor network traffic and then match signature against tri-micro threat intelligence and so on. So it was the typical network monitoring tool that you will deploy. Now, from the, let's say, testing perspective, we had a web interface and SSH, not much. So we concentrated all our focus against the web interface. At SSH, there was nothing interesting. And we found 9OS command injection. We're going to show you some of the most interesting vulnerability we found, which is the one I'm going to introduce now, directory traverse authentication bypass. It was very interesting. And basically what we noticed is that when you log on and then you log off, there were some changes at the operating system level on the file system. And basically we noticed that under the var log folder, you had a folder with the same name of the session ID. And this folder gets deleted every time the log off function was triggered. So that was quite interesting. And of course, this conclusion came after analyzing, studying again, coming back testing approach. You do an action, and when you want to understand what's happening on the operating system, at the file system level, and so on. So we did a bit of studying some of the libraries. So the logoff function cookie you see here calls this delete session, which calls system. And this is very interesting to investigate and see what's happening, which kind of commands. And basically, just to put all together, you see that the session ID is the argument here is passed basically in this command here. So it's removing that folder I just mentioned before. So this is quite interesting. We say, okay, let's try to have a command injection straight away there because we have a system, so why not? The problem is that we realized is that just before the binary MF is called, we have an exstat operation against. So basically, we cannot use illegal characters and so on. So we couldn't really find a way. Maybe it's possible to find a way to escape, but we couldn't find this case. So what we said, okay, what can we do? We can only delete. We can traverse because we can use ... We can traverse. What can we do? Yeah. So that was a little bit of
file needed to exist on the file system.
Yeah, it was kind of constrained. So after some other inspection, we found that this file is quite interesting because it contains the credentials of the admin user. And what we noticed that if you delete this file, so we traverse and we delete it as unauthenticated because it's a logoff function, so you're automatically unauthenticated when you do that. Basically, the appliance becomes like unstable, okay? And whoever is using the appliance as administrator has to restart the machine. In the moment it restarts, what happens is that he realized that that file doesn't exist anymore. It will create a new one using default credentials. So in our exploit chain, basically we delete this file. We know what are the admin default credentials. We just wait for the reboot, which is forced. Otherwise, you don't use anymore the appliance because you can't. And then in the moment it reboots, then we basically log with default credentials, and then a further action is taken. Just gonna skip this. One of the things that how we found this, basically we were running a find search on the file system to search any file which was modified in the last minute, okay? Then we were doing the log off and then run again and see the delta. And in the delta we saw that the folder containing the session ID disappeared, so the log off function must be most likely related to that. And that was one of the key to find this vulnerability. Second one, which we found, it's an upload. This is, I think, it's post-authentication, right?
Yeah.
This was quite interesting because it's a file upload, but there is also a zip operation happening and unzipping. So you upload a zip file and then it will be unzipped. The cool thing, we have a very good suggestion from Andrea Palazzo. And basically, what he was suggesting is this. Okay, let's first upload a zip file which contains a symlink, okay? Let's say A, pointing to a certain directory, okay? And then you upload a second time, another zip file, which use the symlink which has been previously created, but then try to possibly overwrite or crash an existing file on the system.
So I'll tell you why quickly we went that approach instead of like a traversal. We just simply couldn't do a traversal, right? And any file we got uploaded that wasn't a zip file, it would do like a checksum or check of the headers and things like this. It would just delete and not do anything with. So we couldn't just upload like PHP and we're done. We had to like upload actually a compressed file, and we'll try to decompress it. And then when like I said, when we have traversals in it, it's like, bad file, and just delete it. So we had to go for a little bit more interesting approach, say.
So you see here the first part of it's the C symlink created, okay, which points to this. We need to have the base folder right here. Then the second zip will actually use the C and then crush this shell script right there.
Yeah, the DLP_kill was ironic. I thought it was funny. So we just used this file, and this was executed.
We used this file because then we could call a request which would call that shell script. So it was chaining different things together. Yeah. So this is the screenshot, and I think we have a demo same style as before.
Yeah. One sec, I'll just go back to here at this one. So it might be hard to see, but you can see that, like, you know, for example, do the initial pre-flight, upload the zip symlink, and then because we couldn't actually upload a single zip and have the symlink and the target file to overwrite with in the same zip, but what happened was we were able to upload one zip, it decompress, create the symlink, upload another one, decompress it, and write into the symlink directory. And this worked because it was actually unzipped in the exact same folder. It wasn't creating like a temporary directory or anything like that. If it was creating a temporary directory, this vector wouldn't have been able to be used, and we wouldn't be able to get code execution from it. So it was kind of interesting. And then, like Roberto was saying, we could call like an API in the CGI interface that would automatically execute the DLP_kill.sh file, which we thought was ironic, and it would kill the actual application, but really execute our code, and away we go. So, sorry, that was fast, but...
Yeah, thanks. And this is the demo just showing all together this vulnerability. As I mentioned at the beginning of the presentation, because it's the first time we release all this research, we are actually dropping all the unpublished exploits we found on this threat discovery appliance. In the moment we finish this presentation, I understand the presentation will be already shared on Twitter, will be online. And in the presentation, you will find the links if you're interested.
So what this exploit is doing is actually just overriding or just deleting the file, and it's basically waiting for the admin to reboot, right? Because once you delete the configuration file, the admin can no longer log into the admin interface, and the natural thing for an admin would be like, okay, this application's not working, I can't log in. All right, let's just bounce the box and see what happens. Or isn't that kind of like a natural mindset, I would imagine? And so they would bounce the box, and then our exploit would do a polling request, right? And it would poll the server and it would detect that it's down, okay? And then it would detect it. And then as soon as it comes back up, it'll try to log in with the default user account, default password, log in, start sending the payload, upload a shell using one of our post-authenticated bugs, and then, yeah, delete the temporary file if it created one, and execute code as root user, I believe. So, you know, it's all about, for us, it's all about chaining these types of vulnerabilities to give us like basically a direct way path into the target. So.
These are the links. Here you will find the links when you download the slides. These are the links which contains every exploit we're releasing today as a bonus for Hack in the Box conference. And we have more as well. And we also have a pull request. I think probably, I don't know if it's still accepted.
Yeah, it's still up there, the pull request. I think we're waiting on the acceptance of that. And then, yeah.
Cool, I'll leave it to you.
Yeah, I don't think we have time for mobile security. Do we? Okay, I don't know. But
go fast.
Basically, yeah, it's you know, a central solution for mobile devices. Nope, we're out. Okay, well, we have to end, but yeah, we'll play the demo nonetheless. But there we go. So, but yeah, this one's still 0 days, so we can't really disclose this one. All right, I think that's it for this session. No? Oh, okay, yes, sorry. Question and answers, if anyone...
We'll do a couple of questions, if there are questions from the floor. I believe there was a raised hand. Let's start with you first, and then over.
What? Hello? You said that you wanted exploits without user interaction, but if the admin has to reboot the system, that's user interaction, right?
It's true, that is part interaction, but when we're looking at things like this, we look at what, like we think from a logical point of view from the admin, we didn't have to tell them to reboot it. Naturally, that they try to log in, and it would be like, well, we can't log in. The most natural thing to first do is reboot it, and then try to like figure out what's going on. Maybe they reset the password or something, you know. And by that time, we've already got a shell. We've already migrated, processed, and taken over the box and whatever, and implemented our kernel rootkits. So
it's a good question. We call user action,
good question,
no interaction.
Any other questions?
Sorry, just out of curiosity, have you also assessed the Trend Micro virtual patching?
The which one, sorry?
It's called a Trend Micro virtual patching.
No, I don't believe yet.
You haven't tried that yet? Okay.
No, but we'll put it on their list. Thanks.
Let's put it.
Thanks. It's on our hit list now. Any other questions?
Yep. I want just to say, I mean, it was a great talk. At least very interesting for me, and also I guess for the rest of the audience here, because the vulnerability you presented, they are very different among each other, right? I mean, at least we learned something from your research, so it's very useful for us and also for you guys. And I also think it's a good example of collaboration, successful collaboration between researchers and vendor, at least because you had a good response from a vendor.
So I was struggling to understand. Sorry.
No, I'm saying it was a good example of collaboration between a vendor and the researcher.
Yeah, totally. I mean, we had the reason why we went this far with these products and with Trend Micro is because they were so cooperative, and it was fantastic to see. You know, we were really impressed with it. They had proper advisory. They patch it quite quickly. The turnaround time, and they always update you with statuses and stuff. So it was really good, really smooth. Outside of the whole, they have their own bug bounty program and things. They were really, really good to deal with. So yeah, fantastic. Any other questions?
No other questions?
No?
Right. Okay, well, thank you very much, Roberto.
All right, thanks a lot.
Thank you.
Thanks, guys.
Thank you.